This project is about designing an electromagnetic levitation system that is controlled by a PID controller to hover a lightweight magnetic object. A sensor is used to give feedback to the system on the position of the object, and the controller balances the gravitational force against the electromagnetic force of the solenoid at its equilibrium position in order to achieve levitation. Design goals: to learn about PID controllers, sensors, feedback, levitation, and project design, and to levitate the object. Control principles. A PID controller is composed of three components. Proportional control P depends on the difference between the set point and the process variable. This difference is called the error term. Integral control I is the sum of error over time. Derivative control D is proportional to the rate of change of the measurement or error. Values of the PID are set depending on how the system reacts to small disturbances. Controller. We used an Arduino Uno along with its own program and PID library as the controller. For our initial design of the Levitator, we had a MOSFET IRF740 acting as a switch to the electromagnet. Through feedback from the sensor, the Arduino controls the strength of the solenoid. For part 2 of our design, we changed the MOSFET IRF740 to an L293D H-bridge that could reverse the polarity of the electromagnet whenever the magnetic levitating object is too close. This portion of the code initializes the parameters and sets up the inputs and outputs. This portion of the control converts the time it takes for the echo to return to the ultrasonic sensor into centimeters. In the bottom, it shows how the ultrasonic sensor works. First, it sends out a high pulse, and then it waits for the pulse to come back, and then it turns it off. This portion of the control computes the PID and outputs a value towards the solenoid. Results. For our outcome, the object would either be sucked onto the magnet or dropped. There were rare points when the object felt supported by the solenoid in midair. And for our conclusion, overall, we're not able to levitate the object due to poor readings from the ultrasonic sensor. The levitating object would either fluctuate too low or too high. The ultrasonic sensor was very poor at reading small objects to levitate. It had to be perfectly aligned to the object or the readings would be off. It worked best when blocked by a larger, flatter object. The ultrasonic was too slow to react to changes in the system due to its three-step process of sending a pulse, waiting, and processing the echo formation. Engineering 4220 Feedback Control Levitation Project Team 2. We're using our Arduino to control the output towards the solenoid. The input comes from the ultrasonic sensor, and it measures the distance of the levitating object. The program uses a PD controller that takes in an input and a set point, which is the location of the object where levitation is achieved. The program computes an output adjusting the amount of electromagnetic force the solenoid emits. And let's see. Right now, it is displaying 15.45 centimeters. Which is just the distance from the ultrasonic sensor to the electromagnetic. See, when it hits a set point, it would try to correct itself, pulling it back stuff up. That's not really working. There's also the problem with the sensor. Any changes to the position of the sensor of the levitating object, which actually changes the sensor's readings. You can see from here. Jumps around a lot. In the 20s and 10s sometimes. Which isn't where the actual levitating object is. Quick change to the schematic. I've added a 293D H bridge, which now allows the circuit to switch the polarity of the magnet, repelling the magnet, the levitating object, whenever it gets too close. But it still doesn't work. So.
All right, that's it. Dishonor. Dishonor on your whole family. Make a note of this. Dishonor on you. Dishonor on your cow.